Can I really make a game without coding? Hey guys, welcome back. I have something for you. Some damage is what we'll be taking today, and with it our first lines of code. This is a perfect opportunity to go over private versus public that we see here. But to make things a bit easier to understand, let's zoom out a bit. This is a game object. The player and the base platform are different game objects, and each game object can have its own scripts. That's right, multiple. You can have more than one script on a game object. When you make a public variable, the visual scripting equivalent of that will be an object variable. Any of the variables here can be accessed by other scripts within the game object, and they can be seen and changed through the variable tab. While private variables in this case will be graph variables. Graph variables are hidden and can only be accessed by the internal script itself and doesn't share to the other scripts in the game object. With that out of the way, let's get started. I think this would be the perfect place to make a new visual script. We can start by disabling our old one. By disabling, we are able to keep and save the script that we made before, but not use any of it at the moment. We will name this new script Take Damage and build a new script in here. Even with the player information script disabled, we can still see the public variables we made in it. We'll start by making a new variable called current HP. Since it's public, we can set it up to be an object variable. The next line is a lifecycle event. Once the game starts, it will trigger the function to take damage. With the damage itself being an integer of 25, in order to make it work, we need to make the function itself. Remember that we can do that by making a subgraph. Inside of the subgraph, we can build the script. Get variable current HP minus the damage, which would be set variable. And that should be everything. Now that we have the function, we can go back to the second line and finish that up. We make the damage integer private, and that way it's hidden. The reason I made it like this is because I want to be able to change the damage without having to go inside the subgraph every time. It's time consuming and overall not very effective, since we want to be able to use the same function in different situations, or fights in this case, and by taking the damage outside of the subgraph, we can change the variable according to the situation and have it work in every case. So we have the onStart event and we have the damage variable. And finally, the subgraph. If you remember, we can plug in the event with flow by selecting the input node inside of the subgraph and adding it in the trigger inputs. But what about the damage? We can also plug this into the function by going and instead of selecting trigger inputs, we choose data inputs. This lets us add data from outside of the function and bring it in and run it through the script. And with that, our code works. And now we're taking damage. Finally, we're onto movement. You know what that means?
Can finally play the game. Oh yeah.
Alex started by deleting all of his code since it was just practice. Kinda shattered my heart a bit. After all, putting all that effort into figuring it out, I had to say goodbye and start fresh. When it comes to movement in Unity, there are built-in components that help speed up the process. Since this is a 2D game, we have to move in two directions, X, which is horizontal, and Y, which is vertical. Lucky for us, Unity gives us rigid body, which adds physics to game objects. Using visual scripting, we can manipulate the physics in the game objects to make it move the way we want, and still reap the benefits of the other physics properties. I don't know what I would do without Alex. He does an amazing job explaining everything. I want to continue to pass that knowledge on to everyone and help you guys understand how all this works. As always, let's start with the first line, public float x input. Now this is a new variable that we haven't come across yet. Instead of having a value that we ourselves place, it'll return a number that will be changed by certain events. So when we create this variable, we can just leave it at 0 for now since it'll be changing often. This would be a good spot to explain graph versus embedded that you may have noticed when making scripts. This goes hand in hand with private versus public. It's actually quite the same thing, but it takes a step further with how it's saved onto your computer. When a script is saved as a graph, it gets saved onto your computer and you are able to access it on different projects. Copy it, move it, and even share it. It's a file on your computer after all. On the other hand, when a visual script is saved as embedded, it's saved only on this project and cannot be shared or accessed anywhere else, and once it's deleted, it's gone. So be very careful when you choose to make scripts embedded. I recommend them for quick private code that doesn't need to be used anywhere else, which is perfect for this situation. We'll start by making a second script that will be embedded. You can see that it's not saved onto the project like the other ones. It's saved internally onto the game object. From here, we're able to use the update lifecycle, which if you remember, updates on every frame. This is perfect because we want to be able to know when the player presses the button and in which frame it does, and which is why we're using it for movement. The reason we made the X input variable public is to see if what we did was correct. By pressing the A or D button or the arrow keys, we can see that it changes to -1 or 1 depending on the key we are pressing, which updates on every frame. As you can see, it gradually goes up or down to -1 or to 1. We can actually change it to reach maximum speed in the other direction instantly by swapping it out with get access raw. As you can see, it does the same thing, but it changes so much faster, which probably would make more sense if we could see the player move. In order to make the player move, we want to be able to have access to Unity's physics components with visual scripting, just by searching them up and getting the corresponding node for it. If you take a look at the code, he's accessing rigid body's linear velocity data and manipulating it. Linear velocity is the rate in which an object moves along a straight line, not to be confused with angular velocity, which is the rate in which an object rotates. Since we're moving straight x and straight y, they are both linear velocities, and have their own data inside of the component, as you can see here with vector 2. We're separating the x and y and telling Unity that we want the data to coming from x input and y just by being itself. If we set it to 0, we're telling Unity that it can't go up or down at all. By having gravity, we aren't allowing the data to be affected. We will essentially float it in the air. That's why we want to keep it the way it normally is in this case. We can do this with visual scripting in the following way. There you have it, we have movement, but the problem is that we are only allowing the player to move at the max speed of 1, which is not fast at all. We have to set up our own speed. We can do this by making the move speed variable and then multiplying the x input. Since the x is going to 1, anything multiplied by 1 is itself. And now we have the negative and positive speed of anything we decide.